In this slide, the asset under PD measurement is an oil transformer at a chemical plant in Jurong Island. This was done in January 2016. Two PD sensors were used. The first one is TEV type, transient earth voltage. The second one is airborne ultrasound. This slide is the measured PD signal using TEV sensors. TEV stands for transient earth voltage. Transformer 1 has evidence of PD, and it is from the double hump characteristics of 180 degree separation and spread across the 50 Hz voltage cycle. Transformer 2 is an adjacent unit of similar design. The measured signal is constant across the 50 Hz voltage cycle and indicate background noise. This slide shows measurement from airborne ultrasonic sensors. Transformer 1 shows 5 ultrasound measurements at 5 different locations around the transformer. The blue curve has wholly separated from the other curves. This indicates the blue curve has much higher amplitude of ultrasound. There is abnormality. Transformer 2 shows a similar transformer where all 5 ultrasound measurements are identical. This indicates no abnormality. This slide shows the defect. There was ingress of rainwater into the 22 kV cable box and due to a defective gasket. The transformer was outdoor and without a shelter. The last inspection of this cable box was only 12 months ago. This slide shows the asset under PD measurement was a 22 kV GIS, which was done in May 2018. There were 4 PD sensors used. The first PD sensor was the ultrasonic type. The center frequency is 40 kHz with a bandwidth of 2 kHz. The second PD sensor was the UHF of capacitive type. UHF or ultra high frequency is from 300 to 3000 MHz. The third sensor was the HFCT type. HFCT or high frequency current transformer is from 3 to 30 MHz. The fourth PD sensor was the TEV type. Transient earth voltage is from 3 to 80 MHz. In this slide, the PD measurement was from ultrasonic sensors. The left box shows evidence of PD from the 2 humps of 180 degrees separation across the 50 Hz voltage cycle. The right box shows the measurement after the rectification. Notice the measured signal is constant across the entire 50 Hz voltage cycle. In this slide, the PD measurement was from UHF sensors of capacitive type. UHF frequency is from 300 to 3000 MHz. The left box shows PD and evidence from the 2 humps of 180 degree separation and across the 50 Hz voltage cycle. The right box is after the rectification work. The measured signal is constant across the 50 Hz voltage cycle. This indicates background noise. This slide shows PD measurement from HFCT sensors and in the frequency range of 3 to 30 MHz. The left box shows PD and evidence from the 2 humps of 180 degrees separation across the 50 Hz voltage cycle. In addition, the time domain analysis shows an impulse waveform with a very steep rise time. This further indicates PD. The right box shows the measured signal after the rectification. the measured signal is constant over the 50 Hz voltage cycle and indicate background noise. Time domain analysis does not reveal any impulse type waveform with steep rise time. This further indicates the presence of background noise. This slide shows PD measurements from TEV sensors, transient earth voltage type. The left box shows PD and evident from the two humps of 180 degree separation across the 50 Hz voltage cycle. The time domain analysis shows an impulse waveform with steep rise time. This further indicates PD. The right box shows measurements after rectification, and the signal is constant across the 50 Hz voltage cycle. Time domain analysis shows the waveform without steep rise time. Both analyses indicate background noise. This slide shows the defect at the cable termination of a 22 kV GIS. The cable termination is the fully screened type and connected to a Type-C interface at the GIS. The L3 phase had pitted and discharge marks. The possible root cause is insufficient grease, wrong type of grease, cable lug not tightened to the correct torque level, or loose insertion of the cable termination to the GIS. This ends my sharing for online PD measurement. If you need further information, feel free to email me and I will be very happy to get back to you.